Hi all, hope you have gone through the previous tutorial covering need for semantic analysis, semantic errors, syntax directed definitions, what is an attribute grammar, what are the types of attributes like inherited attributes, synthesized attributes, annotated parse trees, etc. So this tutorial is a continuation of that, and in this tutorial we'll be discussing the different types of SDDs. Now we can have two types of SDDs. Okay, S attributed definition and L attributed definition. So an S attributed SDDs, here S stands for synthesized. Okay, so if an SDD uses only synthesized attributes, it is known as S attributed SDD. Okay, if all the attributes in the SDD is synthesized attributes. So what are synthesized attributes? They will get the value from their children, right? If each and every node get their value from their children, it is known as synthesized attributes. So if all the attributes in an SDD is a synthesized attribute, then we will call it as S attributed definition. Now here it's an example, giving BC. Here a dot a equal to b dot a, that is, this a got the value from its child b, or it can be from the child C. So this is an example for S attributed definition. Now here they are evaluated in bottom up passing. Why? Because after getting the value of child node we will get the value of its parent, right? So it will be evaluated in bottom up passing. And here the action in the last class we discussed that for every SDD there will be an attribute associated with production, and attribute will get a value, and we will give a rule for evaluating it, right? So semantic actions are placed in a rightmost place of RHSs in this S attribute definition. So A giving BCD, the rule will be placed, or its action will be placed at the end within the curly brackets. Now L attributed definition. So this L attributed definition will contain a combination of this inherited as well as semantic attributes. So what is inherited attribute? The value of a particular attribute will be getting either from a sibling or from a parent, right? So a combination of this will go to L attributed definition. So contain both synthesized and inherited attributes, but no need to build a dependency graph to evaluate them. So what's the definition? As SDD is L attributed if each inherited attribute of xj in a production A giving x1, xj, etc. up to xn depends only on, okay, this L stands for left to right. So whenever there is an xj attribute, it should get value only from x1 to xj minus 1. Okay, so that is attributes of the symbol to the left of xj, that is from x1 to xj minus 1. The xj should get the value only from attributes of LHS, and it can also have inherited attributes. See an example, A giving BCD where B dot A equal to A dot A. So this attribute got its value from the parent node. Now C dot A equal to B dot A. This C dot A got value of attribute of B, which is to the left hand side of C. So it is also possible. But see, here C dot A equal to D dot A. Here the value of C we get from D, which is to the right of C, and it is not possible. So that is why it is said that if an SDD use both synthesized and inherited attributes with a restriction that inherited attribute can inherit values from parent and left siblings only. That is why it is called L attributed SDD. Okay, and here the evaluation happens by depth first and left to right parsing, depth first parsing and also left to right parsing. And here the semantic actions can be placed anywhere in RHS. In the case of S attributed definition, it was in the right end of the RHS, but here it can be placed anywhere in the RHS. So we can say that if an attribute is S attributed, it is also L attributed. Why? Attribute is S attributed if all the attributes are synthesized attributes and also the semantic actions are placed at the right end. So these two conditions are satisfied in L attributed also. So we can say that if an attribute is S attributed, it is also L attributed. Now, how evaluation of L attributed SDD takes place. So it's already discussed. First, we have to evaluate bottom up way and from left to right. So they are a class of syntax directed definitions. Attributes can always be evaluated by single traversal of the parse tree. Following procedure is taken. So algorithm L evaluated of n node. Now input is node of an annotated parse tree or root, and output will get attribute evaluation. Begin. For each node or each child m of n from left to right, do begin evaluated inherited attributes of m. We are getting the inherited attributes if they are for each child m of n, and we are also getting synthesized attribute. Evaluate synthesized attributes of this n. And now this is an SDD for a desk calculator, or it can also be used for evaluation of expressions. Okay, this SDD is very important. You have to by heart these predictions as it is usually asked in university exams as essay question. So they will not be giving the predictions to you. You have to write the prediction your own. Okay, so let us see the predictions. L giving En, E giving E1 plus T. I have already explained why this 1 is given as a suffix in order to identify it from the head. E giving T, T giving T1 star F, T giving F, F giving within a, E within symbol bracket, and F giving digit. Now we have to evaluate an expression 3 into 5 plus 4n using this SDD both in bottom-up approach and top-down approach. So in some question you will be given an SDD and you will also be given an input string for passing, and they will specify which passing method you should do. That is either bottom-up or top-down. So here I am discussing both the types. Okay, so first step is for look up for bottom up approach. For that we have to draw the parse tree, then you have to traverse from top to down and left to right. Okay, and whenever there is a reduction, go to prediction and carry out action. This sentence you have to keep in mind. Okay, whenever there is a reduction, go to the prediction and carry out the action. So this we will see when we are doing that. Okay, now this is our string 3 into 5 plus 4n. So first we have to create parse tree for that. So we'll start from the start symbol L giving en. Okay, now what you have to give, we have to get this. So next prediction I'm going to give is E giving E plus T. Now again I have to get 3 into 5, right? So I will be substituting E by T. Then I will be substituting T giving T star F. So this is my parse tree. Now for F I have to go for digit. Then only I can enter these digits, right? So I am giving T giving F, F giving digit. Here also, so everywhere I have given digit. So this is our parse tree. Now what you have to do is you have to traverse top down. Okay, so I have traversed through here, and here I have seen a reduction, right? Dig dot lexval. This is digit dot lexval, right? So I have the number 3 here. Okay, So whenever there is a reduction, go for the prediction. F giving digit is the prediction and perform the semantic action. What is semantic action? F dot val equal to digit dot lex val. So here there was we had an value or reduction. I perform the reduction and went for the production. Whenever have a reduction, go for production and perform the semantic action. Action is f dot value equal to digit dot lex value. So I have to give this digit dot lex value to f dot value. That is what I have given here. This digit dot lex value is given to f dot value. So here also I have a reduction, right? So this f dot value. Okay. Now we will again give we will again look for the production. So what is the production? T dot f, right? T giving f. So what is the action? T dot value equal to f dot value. So I have to give this value to T dot value. Okay. Now again we will move up from, we have to move top to bottom and from left right. So here there was no reductions. Here only I got a reduction. Whenever we have a reduction, we will go for production and again semantic action. Hence I got reach up to this. Now T dot val, there is nothing. Here I have a digit. Here I have a sim. So here I should have some. Here means there is nothing. Again I will reach here. So this is a reduction. So again same will happen. So digit dot lex val, I will get the value as 5. Okay. So I got the value as 5. Whenever I perform a reduction, I will go for the semantic action. So again, f dot value equal to digit dot val. I substituted 5 here. So here t into f. So this is a reduction. We can go for reduction, right? So we will go for reduction. Whenever have a reduction, go for production and perform the semantic action. The semantic action is 3 into 5. So I will get semantic action t value equal to 15. So I got it. Again I have a reduction. Again I go for production and the corresponding semantic action. Hence I substituted the value t value for eval. Okay. Now e value here plus here we have t value. Okay. But I cannot do the reduction now. Again I will go to bottom. So here I have digit dot lex val, that is 4. So I perform the semantic action. Here also semantic action perform. Here also semantic action perform. So this can be reduced. Now this can be reduced to get 15 plus 4, 19. So I got this reduction, again this reduction. Okay, this is how we will go for bottom up parser. Go from top to bottom and left to right. Whenever you have a reduction, go for production and perform the semantic action. Now we will see the top down approach. Okay, so first we need to draw the path tree similar to that of bottom up, then traverse from top to down, left to right, similar. But in this case, we have, whenever we come across a semantic action is performed. Okay. In the case of bottom up, we found the reduction, then go and then went for the corresponding production and then for semantic action. Here, whenever we come across a semantic action, we will perform it directly. Okay. So this is a procedure and note for each new child m of n from left to right. Do visit m. Evaluate semantic rule at node n. Okay. So this is the same string that we have to find. But differences we are doing top down passing. Now see, these are the predictions that I am using for here. Okay. So L giving en, A giving e1 plus t, E giving t, T giving t star f, T giving f, and f giving num. So these are the predictions. And what I have to do is I have to number the semantic actions. For each prediction we have a semantic action. So you have to number the semantic action. I'm giving this Roman number 1, then natural numbers 1, 2, 3, 4, and 5. Now the next step we have to do is whatever semantic actions you are performing, you have to number at that node. Okay, so here L giving E and I have numbered as Roman 1, so I'll give it as Roman 1 here. Similarly, E giving E plus T, semantic action is number 1, I will give it natural number 1 here. Similarly, E giving T, it is number 2, I will give number 2 here. Then T giving T star F, I will give number 3 here. T giving F, I will give number 4. F giving num, I will give 5. Similarly, I have to give at every substituted nodes. Okay, so it will look like this. For every nodes, I have given the semantic rule number. Now, what you have to do is you have to traverse from top to bottom. Okay, from top to bottom, you have to traverse. And whenever you see a semantic action, okay, then you have to directly perform that. Okay, so here we have a semantic action file. Here L giving E giving E1, E1 giving T giving T1, T1 giving F giving digit. Now this digit here you have to perform the semantic action number 5. So what is 5? F dot value equal to number dot x value. So I will give the value of 3 here. Okay, then moving on you will get a number 4 prediction. Okay, number 4 semantic action, so that is t dot value equal to f dot value, so I'll give 3 here, t1. Now again I will have what a semantic action we perform here number so top to bottom and left to right again. So we will move there, here we will get 5 again, I will give number 5 here. Moving on, I'll get 5 here, so I will get 3 into 5, 15 over here. Okay, so that is 2, right? So this way we will move on and we will get, so the valuation, I am moving from down here I reach and I got the value 3 as a result of 5, and I substituted the value here 3. Then again I got 4, I am substituted the value 3 here. Then again coming down I substituted value 5, substituted here, and I got 3 into 5 as 15 here, right? This is a semantic action tree. Now again moving on, I got value 15 as a result of 2. Then again here I don't have any semantic action, so moving down I got here semantic action 5, so substituting 4, evaluating, finally 15 plus 4, 19, and semantic action 1, substituting L value as E value with this production capital or Roman number 1, and I got 19. So this is the difference between top down and bottom up. Understood? So go through this tutorial well. Thanks for watching.